So, hello, welcome to API Hacks, and I'm Pranav, and this is Karan Balkar with us. He's an he is an API. Uh, at he works at LTI, and he'll be telling us about his vast experience in APIs and how to use them in building apps. Today's theme is space apps, and over to you, Karan.
Okay, so first of all, thank you so much, Pranav, and thank you to the API Hacks team for inviting me. So let me quickly share my screen. Okay, so today's topic is about building space apps using an API first approach. So I hope my screen is visible.
Yeah,
So
Karan, your screen is visible.
Okay, okay, okay. So before we begin, first of all, thank you everyone for joining this session. And today's session is going to be focused mainly on two things. So one is about, of course, building space apps, and how one can do it is also the second, focus point as well. Now, before we begin, a short disclaimer. So, this session is actually not about developing apps in space. It's going to be basically talking about how one can develop apps about space and how you can, showcase space data. And it also will talk about how one can, use this kind of an approach, which I'm going to talk about in especially in terms of hackathons and events which have a limited time frame. So this is basically the objective, or I would say the outline of this presentation. So a brief introduction about me. So my name is Karan, and I've been working primarily as a mobile app developer. So I've been working as a developer for the last 5+ years now, and I have been actually working also on cutting edge technologies like AR, VR, and AI. And since the past few years, also have been working on DevOps and DevOps based implementations in my organization. And apart from being, I would say, passionate about technology, I also love writing poems, traveling to different places across the globe, and also meeting new people. So, that's about me in a nutshell. Now, coming to the topic, for today, before we actually talk about APIs, just a little background. So, this term is quite familiar, right? APIs is something that every one of us knows, and these web APIs, or I would say the APIs in general, have been there for quite some time. So, it has been like more than 2 decades right now. And but the early work of this this foundation was done by three gentlemen, and these it is very important to mention them here. They are mainly Morris Wilkes, David Willer, and Stanley Gill. So these three people actually were the ones who laid the initial conceptual work about what exactly an API would be, what would be the idea of an API. So it was their work that actually, because of which today we are actually using APIs. So APIs, they it was based on the research or the study that they had conducted. It was decided like APIs needs to be designed, of course, and they need to be managed as well. And for that, one needs to come up with or define a particular contract. So a contract basically can be any, like an agreement, you would say. So an agreement is like an agreement between two parties, or I would say a group of in case of software projects, maybe in a team. So this contract has to be defined, of course. And then if you see, software development has been increasing ever since this particular term or this particular technology has come into existence. And there was always a need for a new way of development of apps or development of software. And there is where there was a need for a new approach and a new strategy. And that is where a new strategy was formed, and that new strategy is called as the API first approach. So before we actually come to what exactly is an API first approach, let's talk about the approach that we are most familiar with, or I would say most of us use this approach, which is called the code first approach. So the code first approach, or you can say the integration approach, is something that we are all familiar with, right? So let's take a simple example. So let's say you have a requirement that you have come up with in a project, which is to implement a login page, right? A login screen. So based on the requirement, the backend team would first start developing the API for login, and once it has developed the API and tested it locally, they would then send the API to the front end team, or you can see the client side developers, to then consume it. And this approach would basically end up saying that if there is a change, suppose if there is some change that has to be done, then the client team would basically, or the front end team would basically inform it to the backend team, and then they would do that. So if you see, this approach is actually kind of synchronous in nature, where it's like it's going like step by step. There is no parallelism involved in this. And these kind of approaches, although they are used with majority of software projects, actually tend to fail also at most times. So there was definitely a need for a new kind of approach, and that is where the API first approach came into picture. Now, what exactly is an API first approach? So as a name suggests, it basically means to write or develop APIs before even going or writing the actual code. So that is the main concept behind API first approach. Now, in this case, the important aspect is that when you're developing the API needs to be consistent and reusable. So, of course, that is one of the factors that you need to consider when you are developing the API. You should also establish a contract. So this is basically the agreement I was talking about between. So there has to be a contract or an agreement between the client team or the front end team and the back end team. So both of them, both the teams should come together and brainstorm and discuss about certain aspects before even finalizing the API. And more focus, I would say, has to be given on the design of the API. So in this case, one needs to actually think about how the API would behave, or what would be the systems that it would connect to. So all these factors needs to be considered while designing the API. So all said and done, so this kind of an approach basically makes sure that you're developing your APIs or your interfaces even before you actually go about writing your code. So this kind of approach actually has a lot of benefits. So what are the benefits of this kind of approach? So some of you might have guessed it by now. One of the main benefits of this approach is a faster time to market. Now, what exactly does this mean? So whenever you're developing your apps or your products using an API first approach, you have a faster time to market in terms of, like, your working product or the final product can be developed much faster, as because when you start developing the APIs and assuming your APIs are ready and they are tested and everything is fine, the teams or the front end teams can easily start consuming them, and you can actually have a more iterative approach where you could actually start consuming maybe some of the APIs and then slowly start building upon the other APIs, and eventually you could do a final rollout as well. So it can be like an iterative or an incremental approach. So here there is of course a faster time to market, because in case of a code first approach, this would eventually take a lot of time, because if there are any changes, you would actually have to go back to the backend team, and this process would continue. Eventually you would not have a product that could be released. But in case of an API first approach, there are chances of you having getting that initial version, or that, I would say, that MVP, or the viable product released beforehand. So that is basically one of the advantages. The second advantage is about parallelism. So in case of a code first approach, or the, I would say, the traditional approach that we are using right now, there's a lot of back and forth and between the teams, and that is basically a cause of concern. Whereas in case of an API first approach, both the teams come together, they are all working in parallel. So one team can, the backend team, while they develop the API, the front end team can consume it, and how they can do it, I'll also be explaining. So this kind of parallelism can be achieved in case of an API first approach. And the third one of the third benefits I have highlighted here is there is a less risk of failure, because in this case you have actually not started writing the actual code. So you have just developed the APIs, and you have tested it using, say, some mock data or some static data. So you know that the application in a way has the capability to consume those APIs, and even if something goes wrong, I would say there is always a lesser risk of things going wrong. Whereas in case of a code first approach, where you have already consumed the API and rolled out maybe a version, and if there are any changes there, that could actually have a more risk of failure. So that in that case, the application would need to be redeployed or something like that. So in case of an API first approach, definitely there is a lesser risk of failure. And one of the benefits that I've not mentioned, although over here, but it's something that worth considering, is that this kind of an approach is actually considered to be more developer friendly, and it has actually no development or lesser development cost, I would say. So you do not actually spend too much time in developing an API, right? So there is there is a developer friendliness or a developer cost which is associated with this kind of approach is actually lesser in this case. So these were the benefits of using an API first approach. Now, how do we go about implementing this? So these are the steps that I have actually listed down to, which are basically used to create or adopt an API first approach. So what are the steps? I would just list it down and I would explain them as well. So first step is to identify. The identification of this has to be of the API has to be in line with your project objectives. So depending upon the objectives of your project, whether you're developing a full SaaS based product, or you're developing a simple app, mobile app or web app, so you have to basically identify that first. And you need to know the overall the ecosystem in which your good application is to be developed. So what are the the backend systems, what are the integration points, so all that needs to be aware. The second thing is the brainstorming part. Here you would actually have to decide more on the API, like decide the type maybe of the API, what kind of API would you use, whether it's RESTful or SOAP based, and the advantages or disadvantages of using that. And after the brainstorming is done, you sit the both the teams, the front end and the back end teams, need to come to a common agreement, which is basically the contract, and that can be understood by everyone. So that is basically the binding glue, I would say, of this whole process, where you actually need to come to a common common ground or a common agreement. Now, once this is done, once the contract has been created, you then need to basically translate this. So now translation basically would be done using something called as the Open API specification. So I'll be talking about this in detail in the subsequent slides. And once the translation has been done using a well-known or an open specification, it's now time to implement it. So here is basically where you will start implementing a set of APIs or services, and that would respond basically to the client with certain set of static responses. So that will basically, you can call it as mocking or mock, we call it as mock backend. So that is basically the idea. And using this kind of services, the client can actually start generating, you could write some stubs that you could actually try to consume this kind of static data. Eventually this kind of static services would then be, once it has been you have tested it, you can easily move it to maybe a staging or a production environment with the real data. So that is one of the advantages you get in this kind of an approach, where you could actually based on whether the services are have been tested thoroughly from the client side, you can actually have that switch in place, where you could easily switch from maybe a development environment to a staging or a production environment without affecting anything on your side as well. So that is basically one of the advantages of this kind of approach as well. So once the generation is done, you actually have created your APIs, and the client has also consumed them. That is where I would say the main part or the main step has been done. And now it's where you actually have to maybe fine tune or refine your API. So that is where the maintenance aspect of the APIs would come. So how do we go about this is also something that I would like to show. So I will move now to my code editor. So I have a project that I had developed specifically using an API first approach. Now, this project, before I come to this project, there is also something that I need to say. So this project basically is developed or is based on the concept of microservices. So for those of you who are familiar with Spring Boot microservices, can easily adopt this as well in your existing project. Now, to use this kind of services, first of all, you need to understand what kind of app that you are going to develop. And here is where I would like to first talk about the concept of space apps. So every one of us, or maybe most of us, I would say, ever since childhood, would love to know about what exactly happens in space, right? So everyone has this has this dream to understand like what exactly is happening out there, what kind of images are being captured, etc., on other planets. So there is definitely some curiosity that is associated with this kind of data. And that is why I believe that this kind of applications can be developed. And the good part is that you can easily develop them using APIs. So one of the main reasons of choosing this particular idea was that there are a lot of things that we already know about, or the data that we have about space, but then we need something that to consolidate this data. And APIs are basically one of the mechanisms by which you can pull in data from several sources and you can actually consolidate them. So in this case, for example, if you need to know about the Mars rover mission, or for example the various asteroids or other space bodies, in that is where the information about this can be also achieved through APIs. And how that is done, I will also demonstrate now. So this is basically to give you an idea about what exactly are we trying to do over here. Now coming to the code again, so let's say I have to develop a particular app which basically gets the picture, for example, or you can say the astronomical picture of the day. So let's say you want an API to be developed, or an app to be developed that can have an API which will get you the astronomical picture of the day. So let me point you to another source. So NASA actually has an API like this. So NASA is has a public API which it has already exposed. However, this kind of APIs have a lot of limits. So therefore, there is of course a limit that has been associated with this. So for you as a developer to come up with something like this, you need to have, maybe you need to create maybe your own API. So this is where you can leverage the API first approach. So how can this can be done is what I will show you now. So this is basically a project that I had created that will show how we can actually develop an API using an API first approach. So the first step basically would be to write our API specification, right? So here is where I have actually used that. So I have used the approach of OpenAPI. I have used the specification, OpenAPI specification, to write my contract. So this is basically a simple YML file. So for those of you who are familiar with YML, it's basically a data generation language where you can actually specify some content, and that content basically is your that holds all your information. So it's like similar to JSON, but then it's a different kind of a different kind of, I would say, extension in that case. And you can actually write this format based on the OpenAPI specification. So here is a simple file that I have come up. So this file basically contains these things where you can have your title. So this, in this case, my title would be like, say, a space app. You provide an optional description. So this description can be any description. And the main part of here is of this particular specification is to come up with the path. So in this case, I have defined a path called as the planetary slash apod, which is basically stands for the astronomical picture of the day. So, and this basically path is basically going to be my endpoint, and this endpoint is of type get, and this endpoint has certain operations, and these operations have certain parameters. So the operation in this case is a simple one, which is basically to get the astronomical picture of the day. And there are certain parameters that I have used, and these parameters I have tried to keep it matching with the parameters that it is offered by the NASA public API. So this is basically where you can actually start defining your parameters. So here is where you could define. So let's say, for example, you have a parameter called date. So this is basically where you can specify. You can specify whether it would be a part of the URL parameters, or it will be part of the query parameter, like the part of the request itself. So that is basically one thing that you can specify. And whether you can also specify whether it's required or not. So that is also something that you could specify in addition to the data types and all those things. So this is basically pretty standard. And you can actually you read about these particular implementation ways, or implementation, I would say, keywords based on the OpenAPI specification that I would also be talking about now. So here is here is where I have actually listed down all the parameters. So I have listed them based on my API specification, and then below I have also listed down the responses. So this basically were the definition of my input parameters, but now I need to also define what kind of response, or what kind of the result I would need to get, right, from the API. So here is where I can define certain responses. So in case of a successful response, I would actually have a particular schema which I would be returning. So this is basically my object. So I'll be talking about this shortly. And then basically you have certain error scenarios where there is, if there is no picture found, or if there is no data, you can actually have a 404 defined. And if there is a no API key, for example, in this case you can have a 401, which is like an unauthorized way of accessing the API. So these are some basic ways by which you can form your responses or form your the API specification. And as mentioned before, so here is something that you could actually use. So here is something that I have used, for example, schemas. Now schemas is also one of the API specifications that allows you to define the schema of your response. So in this case, in my case, the response is going to be an object of type picture, and this object would basically have these kind of properties, like for example copyright, date, explanation. So this is basically the response parameters which will be part of the response object that would be eventually returned. So these kind of things you can actually add or customize based on your API requirements. So this can be easily customizable and added. You can add this here itself and modify so that you need not actually do anything in code. Now, coming to the security part, so this you can also add security to your APIs. So you can actually have an API key in place, which can be used in the header. So anyone who consumes your APIs can hash to pass or can provide this API key. And this API key basically would help you to determine whether the person or any the client who is accessing your API is whether he's the authenticated user or not. So this kind of information can also be specified in this file using the OpenAPI specification. So this is about how we can actually define this contract. Now once this contract is defined and once this has been agreed upon, now is where you actually need to go about and try to generate this particular classes for this particular specification. So let's see, there are two ways to do this. So one can actually do this using Swagger itself. So in Swagger, actually you can get, if you try to import this specification in Swagger, you can actually get this option of generate server and generate client. So this is going to generate the stubs for you. However, I would recommend not using this approach, because in this kind of approach, what would happen is that it would lead to certain compatibility issues. So if you're using, say, a version of Java, or if you're using a version of Spring Boot, for example, in this case, it could actually have a lower version. So it could actually generate some code which would have not good compatibility with the latest version of Spring Boot, or for example Java in that case. So in that case, I would recommend using something that the OpenAPI specification also recommends, which is using a plugin. So for that, what I have done is that I have actually used a plugin. So let me just show you how my specification looks like. So this is basically my Spring Boot project. It's basically a multi-module project. It has two modules. So one is basically the app. The app is basically going to be the app that you will be developing, and one is the specification. So the specification basically contains certain dependencies. So I have used certain dependencies that I would like to use in my particular project. And then based on that, I have also defined something called as the OpenAPIGenerator Maven plugin. So this is basically something that I'm using. Now, what is the purpose of this plugin? So this plugin basically takes in an input specification. So this is basically the YML file that I just showed some time back, and it basically tries to generate the stubs, or I would say the classes for you, and basically put them into a package. So in this case, there will be two packages. The one is the API package and one is the model. Now the model will represent the model of the response. So in this case, the picture was basically an object that I would require, right, as a part of my response. So all these will be created inside this package, and there will be a package for APIs which will actually hold the controller and the corresponding classes for that. So let me just quickly show you how that would look. So if you expand this target, so once you basically run this project, you can actually generate these particular classes. So once you, let me try showing it again. So let me stop the server and let me try cleaning this project. So let's generate this again. Okay, so once it has been, once you try to run this particular, you try to do an MVN install, it would actually generate, certain classes for you. So it has basically generated it. So you can see that inside the target folder, you now have this particular classes being generated. So let me just show you how this would look. So inside the model class, you would actually have your object which is created. So like I said, there is a class called picture. So it's basically using the same name as I provided in the specification, and it has created this these particular methods and variables for me based on what I have specified. And then the main part of this is the API package, where it has already created a controller for me. So this controller basically is going to be the entry point of when I call the API, this controller would be eventually invoked. And this controller, if you see that it actually injects a dependency, and that is nothing but the planetary, or in this case the delegate, I would call. So this is the name of the delegate, it has come up. So this delegate is nothing but, I would say, an interface. So this interface is going to be basically implemented by us. So and once we implement this interface, we could actually leverage the methods. So this particular thing happens, this once it is injected, it becomes part of the application context, so we can actually use that. Now how that is done is something that I will also show you. So this is the delegate I was talking about. So this is the interface, the delegate method, and it has basically provided a method called as get astronomical pick of the day. So that is basically the method that the name that I gave to my method. And if you can see, it has already come up with a default kind of I would say an implementation. So it specifies that if there is if this kind of this kind of a request is present, then it would return me some sample response. So there is an example response that it will return. And if there is no implementation available for this, then in that case it would return a non-implemented status. So that is something that it is doing by itself. Now, what does this mean? So in this case, if someone wants to use this particular interface, one needs to implement it, right? So for that, I have my app, which is basically doing the same. So in this case, I have this implementation class of this delegate defined. So that is basically the planetary, I've given the name as the planetary API implementation. And this basically implements this particular interface and overrides this method and provides certain mock data. So this is basically the data that I was talking about. So this kind of data basically is like a mock data, where you can set some static values, so that the client can actually try consuming it and checking it whether everything is fine and whether the API is getting called. So this is how one can actually start to mock this kind of data, and you can actually go about even writing certain business logic. Of course, the business logic is something that the plugin would not generate for you. So if you have certain business logic, you would need to come up with that over here. So you would need to actually write your own business logic, or rather the plugin won't do that for you. And once you can write the business logic and set the data, you can actually return the result back to the client. So that is basically how easy it is to use this kind of an approach, where you have actually, based on the specification, you have actually even developed the API through actually, I would not say developed by your own, but you have generated it through a plugin, and then you have just written a class which would implement that interface, and you have defined your method. So that is how easy this kind of an approach can be. And it is basically quicker in terms of if you had to develop an API from scratch, maybe write the code for the API from scratch. So that is one of the advantages you can get in this kind of approach. So now let's try running this. So if I had to run this particular app, I could run this application, Spring Boot application. So if I run this application, as you can see, the server has started. So if I go to Postman, and if I send this, or I hit this particular endpoint, so my endpoint is this particular endpoint that it has given me. So if I hit this endpoint, you can see that it has basically returned me the same the same mock information, or the static information that I had defined. So here is where you can actually, so this endpoint or this specification can be then even modified. So if you had to add more parameters, you could always do that by changing the specification, changing the endpoint from the YML file, and you can also alter the response based on the the data that you would like to provide. So this kind of an approach would be helping not only the backend team but also the front end team to understand like what kind of data has been returned and what kind of parameters or expected information for that API, because for everyone the common reference point would be the specification document. So this kind of approach, I would say, it not only helps to save time in terms of development but also gives you faster results. Now, coming to the part where I was talking about the Open API specification. So this is basically the link or the page, the main page of the Open API specification. So one important point to note is that the current version of the Open API specification is 3.1.0. So it is basically the current release. So earlier there was the version 2 which was there. So if you're migrating, say, from if you have a project which you are using maybe say OpenAPI version 2, and if you're planning to migrate to OpenAPI version 3, that also is possible. Just there are few changes that you will need to take into account in terms of how the specification has been laid down for the version 3. So I would say there are some significant changes, but then you can easily do a migration in that case. So that is also one of the advantages you have in this case. So the Open API specification is, as you might have be aware, is basically an open community-driven specification within the Open API initiative. So this has been maintained, by a lot of open source projects, and a lot of people have been contributing towards this. So if you would like to even contribute, you can actually go ahead and you can actually try to read about this. So in the interest of time, I would not have not be able to go much into detail about the specification, but then you can actually read about this specification based on the this link, and the examples that has been provided in this link. So coming back to the presentation, so this kind of approach can help you building apps like this. So I mentioned about APIs, using APIs. So one could actually use APIs. So in this case, you can actually develop a mobile app or a web app in that case, which can consume these kind of APIs, and eventually you could create maybe a solution that could not only help. This is just an example of getting a picture, but you can actually pull in a lot of data from multiple sources, and then create a kind of a use case around around this whole idea of getting data or getting data from the about space, and you can depict it in as the fashion that you would like to depict it. So you can have a lot of UI and elements as well, but at the end of the day, the APIs could actually help you to get this information, and here is where you could actually leverage API first approach as well. So coming to the end of the presentation, I would say, what in terms of ideas, in terms of hackathon projects, I would say this kind of an approach would be very much suited if you're choosing something like if you're developing AR VR based applications where you need to based on the picture that you would obtain, you can actually even show a 3D model, or you can actually create a virtual world based on the information that you have, and then let the user experience that world, instead of him like directly being in space, he could actually experience that. So that kind of use cases can be done using this kind of an approach. You could actually also do a kind of a feature detection. So here is where I think a lot of research has been done, where you can actually based on the images, you could do kind of a feature extraction, where you can identify, okay, like these are the features of that image, and then classify and use machine learning and AI. So that is basically where this kind of approach would also help. And then you could actually use cloud technologies. So here again, like right now the APIs would be like say local, but if you are actually leveraging cloud, in that case you can actually think of scalability. So scalability also is something that it's important in terms of APIs. So you need to make sure that your APIs are scalable, and they are basically cloud ready, I would say. So that is these are the three, I would say, ideas that I thought of sharing with all of you, so that you can leverage this maybe in the upcoming hackathon, and try to basically build solutions that use any of these ideas as well. That I used to compile this presentation. So please feel free to also go through the same. And once again, I would like to thank the entire team of API Hacks, and hope all of you enjoyed this session. So thank you so much.
Yeah, this was actually a great session. Thanks a lot, Karan. And really, those ideas were actually very helpful. I believe our hack participants will really like this. And you explained a very nice topic and perfectly with the code, I think. Yeah, and I hope everyone will go through this and they can even watch the recording. We'll just post it after after this session. And this was a really great session. Thanks a lot, Karan.
Thank you so
I'll be
much.
sharing the links to follow Karan on our Discord as well. Thanks a lot.
Okay, thank you so much. Bye bye.
Bye bye, everyone.